So in the last video we talked about what is the root of an equation. In this video we are going to talk about when the root of an equation must exist. So we have this equation f of x equal to 0 and we have to find the root of this equation. Before we look at the ways to find the root of an equation, we look at this result from calculus. What does this result say? If f of x, this f of x, if f of x is continuous on an interval AB and f of A is, let's say, less than 0 and f of B is greater than 0, means on one end of this interval the value of a function is less than 0 and on another end of the interval, that is B, the value of the function is positive or greater than 0. Then there must exist some C, another number belonging to this interval AB, such that f of C will be equal to 0. Means at that number C the value of the function will be 0, and from the definition of the root of an equation, this equation implies that C is the root of an equation f of x equal to 0. So it means that if we have to find the root of this equation f of x equal to 0, then we have to look for some interval AB such that on one end of this interval the value of the function is negative and on another end of the interval the value of the function is positive. If we are able to find such an interval AB, then there will exist by this result some number C in between that interval such that f of C will be equal to 0, which implies that C is the root of an equation. Okay, let's try to further understand this result. Let's say you have to find the root of an equation f of x equal to 0. So let's look at this function f of x. F of x is continuous on this interval 2 to 7 such that on 2 the value of the function could be, let's say it's 5, which is positive, and on another end of the interval, let's say it is f of 7, maybe the answer is -1, which is negative. So we have an interval 2 to 7 on which the function f of x is continuous. Such that at 2 the value of the function is positive and at 7 the value of the function is negative. Let's look at the graph, the rough graph of this function. We have an interval, let's say 2 here and 7 here, and all we know that the value of the function at 2 is positive. Let's mark it somewhere here above x-axis, and the value of the function at 7 is negative, so it would be below x-axis somewhere here. And we also know that the graph of this function f of x is continuous on the interval 2 to 7. It means that there is no gap or the break in the graph for a function against the interval 2 to 7. It means when we join this starting point with the end point, maybe through this shape, so this graph, this curve cuts the x-axis at this point. Let's say this point is 3.3, suppose. Then since this graph is cutting x-axis at this point, we can say that the value of the function at 3.3 is 0, because on x-axis all y values are 0 and y is also taken as f of x. So here we had the graph of f of x. This graph cuts x-axis at this point, and this point is 3.3. F at 3.3 is 0. So by the definition of the root of an equation, we will say that 3.3 is the root of equation f of x equal to 0. And that was our goal, that we had to find the root of this equation in the beginning, f of x equal to 0. Let's try to understand this through another example. Let's say you have an equation now, g of x equal to 0. You have to find its one root. So first we will look at the graph of g of x. If this g of x, if this function g of x is continuous on, let's say, the interval -1 to 5, means on this interval, when you draw the graph of the function g of x, there is no gap, it is smooth, it is continuous. And you also have on one end of this interval, that is -1, the value of the function g is, let's say, negative, and the value on the other end of the interval, which is 5, g of 5 is positive. Let's also look at this through the graph. Let's mark the interval on which the function g here is continuous. Somewhere here it is -1 and here it is 5. Now we know that at -1 the value of g is negative. So g at -1, somewhere here it is negative, and g at 5 is positive. So somewhere here it is positive. So we have to join this point against -1, this point, with the point against 5, because the graph is continuous. When we join this point, starting point, with this ending point, we get a continuous graph. And you can see that this graph has cut x-axis at this point. Let's say this point is 2. This is the shape for the graph g of x, which was continuous on the interval -1 to 5. And you can see that g at 2 is 0. By this definition, we can say that 2 is the root of equation g of x equal to 0. Now let's look at another example. If, let's say, you have a graph f of x and an equation f of x equal to 0, you have to find its root. F of x is continuous on an interval 2 to 7 such that f of 2 is positive and f of 7 is also positive. This is just one case. Now if we roughly get the sketch from the given information, on x-axis we have 2 and 7, and f at 2 is positive somewhere here, and f at 7 is also positive, maybe it is somewhere here. Now we know that the graph of f of x on the interval 2 to 7 is continuous, so there is no gap for the graph against the curve 2 to 7. So let's say we have this shape. This graph f of x, it is not cutting x-axis at any point. Since this graph is not cutting x-axis at any point, so we cannot see any root for the equation f of x equal to 0. So the point that we want to emphasize on is that if you have to find the root of an equation f of x equal to 0 and you are able to find an interval 3 to 8 such that f of x is continuous on this interval, such that at one end the answer is negative and on another end the answer is positive. So against 3 it is negative, against 8 it is positive. The graph is continuous. So only in this case the graph will cut x-axis, which case where on one end the answer is negative, on another end the answer is positive. Or it could be the other case that on one end it is positive and another end it is negative. Only in this case the graph will cut through the x-axis and you will be able to have some number, let's say in this case 5. So in this case f of 5 equal to 0 and you will say that 5 is the root of equation f of x equal to 0. Lastly, in order to find the root of an equation f of x equal to 0, you have to find an interval AB such that on one end the answer is negative and on another end the answer is positive, and function f of x is continuous on this interval AB. If these two conditions hold, you will definitely be able to find some number c belonging to this interval AB at which the function value will be 0 and you will have c as the root of the equation f of x equal to 0. So that's the condition to find the root of an equation in an interval. In that interval the function must be continuous and on one end of that interval the function is positive and on another end of the interval the function is negative, or it could be the other case that on one end of the interval the function is negative and on another end the function is positive. So root will definitely exist in that interval for that equation.